Hello, everyone. Let's wait a few more minutes before people gather. I'll have my stream open and I'll be right back in a minute. All right, let's start. Today's lesson is Observer and Mediator Patterns. We'll talk about what is a mediator pattern, how do we solve a many-to-many relation problem, how do we solve dependency explosion, what can we do about it? We'll talk about a standardized, well, not standardized, but a problem solved, a mediator pattern done for us in .NET, which is Mediator. Not in detail. We'll talk about it in detail on weekend. We'll then talk about what is an observer pattern today, how to observe and react to an object, what are events, and how does that correlate with the observer pattern, and we'll compare observer to mediator. So, what is a mediator? And to me, a mediator is not someone like in real life who solves conflicts. It's simply someone who knows all the answers and whom you can trust. A so-called guru, you might say. The idea of a mediator is that everyone knows about it and it knows about everyone. And everyone just asks it a question or tells it to do something, and it does. As it does something, it might cooperate with other people, other subjects, other things. And then, based on that, make a decision, do some action, answer the question. And that is the essence of mediator. Don't care about others, just ask me. That's mediator. How does it look like in UML? So if you look at the class diagram and at the official definition of mediator in a design patterns book, it says that mediator defines an object that encapsulates how a set of objects interact. So here we have two dependencies, and those dependencies, making a choice, let's say, if something happens here, I should probably update this a bit. Anyways, if something happens here, you need to use mediator to make a choice depending on this thing. So if something happens in I-dependency, mediator needs to know, the I-dependency 1 depends on dependency 2 actually, but indirectly so. But anyways, when you call foo depends on this one. When this one calls foo depends on this one. So they're both intersected, related, coupled in a way that they depend on one another, logically. However, imagine if you had 20 of those objects. So now 20 of those dependencies would need to know about each of those other 20 dependencies. So it would be an awful mess of connections. And a central point would be needed, and mediator is exactly that. So instead of communicating directly, you communicate through a centralized piece called a mediator. So the implementation of a dependency communicates through mediator, and the implementation of mediator communicates with an abstraction to make a choice, abstraction of that dependency. So a real life example of mediator would be a kitchen. You know, in a kitchen, you have cooks who cook food, and then you have clients who come and ask for an order. And imagine if each client went directly to a cook. Cook me this, cook me that. It would be a mess. Different cooks would need to keep track of what other cooks know, and they would need to keep communicating what is already being cooked, what is already being ordered. But what happens in real life? Well, what happens is that there is some sort of a manager that takes orders. There's a waitress probably that takes orders. And actually, that doesn't even matter that they take orders. There is a waitress, a bunch of them. Then there are cooks, a bunch of them. But there is still, like, in real life, cooks and waitresses don't really communicate together directly. How do they communicate? They communicate through, let's say, an order board. There's usually an order or a manager that comes and coordinates what the waitresses need and what the cooks can cook or what they need to cook. So there is a board or a person, in any ways, a central point that connects both ends, those who demand something and those who provide something. So in a broad sense, mediator simply separates requests and handlers. It decouples the two. And it solves the problem of many-to-many, replacing mediator, putting mediator in between, and replacing many-to-many relation to one-to-many relation, just like in databases. But I won't go into detail. So when you have many-to-many problem, use mediator. Put something in between, centralize stuff, and it will no longer be many-to-many. And if your classes start exploding with dependencies, try to put something in between. Delegate those responsibilities to something else, and it will be a solution to the problem for now. A year ago, I was making a game, and that game was called Japanese Crossword. So imagine a game, basically a grid made of tiles. And the goal of the game, the objective of the game, is to color the right titles. So every time you color a title, you need to check if the game is completed or not. Right? So basically, if the way I implemented, I could have chosen to implement the game so that every title knows about the other titles. So when I, create, when I click a tile, I can check all other tiles from this tile, if they're colored or not. And based on that, decide if the game is complete or not. But isn't that a bit of a mess? Just by looking at this picture, you already see that everyone knows about everyone. And that's just not the way it should be. Logically, when you start making dependencies, relations, and it looks like this kind of a web of dependencies, you should start thinking that something is really not right and you made a mess. And we need to fix that mess. How do we fix this mess? As I said, the answer is mediator. So instead of each tile knowing about each other, now we have a game that knows about each tile. So instead of tiles calling tiles, we have tiles that call a game and a game that calls tiles. So that kind of communication. And in fact, the game itself doesn't call tiles. It just, it kind of does. It calls them to, it knows about their states. Tiles signal mediator to check their state and see if the game is complete or not. As you will see soon, there is slightly better pattern for this specific problem. And actually, I use that pattern to solve this problem, the other pattern. So if you look at class diagram, you basically have a tile implementation that calls the crossword abstraction to check if the game is complete. And we have Japanese crossword, which knows about every tile. And when we toggle a tile, update game status happens, and Japanese crossword goes through all tiles and sees if they're colored or not in the right places and tells if the game is complete or not based on that. So you already might have noticed the problem that even if it's indirect, there is a circular relationship between classes. We don't have a circular relationship between classes, but there is a circular relationship between an abstraction and a class, like loose circular relationship, circular dependency. And that's why Mediator is to be criticized for. However, there are implementations, there are solutions that you can avoid such a smell of design. And one of such implementations in .NET is called Mediator. But the problem with this implementation is that you need more abstractions. And in the end, it might be really difficult to tell what happens when something happens. And when it's necessary to understand what happens when something happens, such abstractions can get in the way. So Mediator is a library in .NET. So it's very similar to the pattern, the name Mediator, but Mediator is a library in .NET Core as well. Well, it's standard library that simply allows us to register handlers and requests. And based on that, we can publish messages, we can get results, we can execute commands, and so on and so forth. And actually, this way is an extremely popular way of managing the flow of HTTP requests in web APIs. It's extremely popular to do it so. Not so popular in lower level APIs where you handle business logic, but when you just route controller actions to the right business logic, it's very popular. And if you want to read more about Mediator, see the full example that I took a snippet of, I recommend clicking on this link. It has all the information needed. I'll actually copy the link address right now and send it in chat. So, Mediator. Again, like most things, there is stuff that is done for us, and Mediator is one of the things that I recommend using. For at least web API, it's pretty darn good. Before we move on, I see there are a few viewers, so I'd like to ask if you have any questions about Mediator. Maybe something is unclear, maybe nothing is clear, but if you are having questions, feel free to ask. Lord Farr said, do you have a YouTube channel where I could watch your previous lessons? Yes, I do. I will give a link to that. Again, I really plan to just clean it up and have two formats, both written and video, because my lessons are too long. They have insight and details, but they're too long. So it might not be the best form of watching. But if you watch the whole video, you can rest assured that you will understand the topic and that you will not be left in ambiguity or in incorrect information. All right, observer. Next pattern I really would like to talk about is observer. Make sure everyone in town knows the latest changes. And it literally is like the town crier, the person that goes around with a bell and tells the latest news in town. And the inaccuracy in this example, in comparison to observer, is that not everyone needs to know about the latest events. Only those people who chose to will, have that option to know about the events. So it's more like if you wanted to come in to some event and listen to what happened during it, that's the observer, basically. So a better example would be a newspaper. You can be subscribed to a newspaper. So newspaper boy would be a subject that delivers the news to all those who subscribe to it. And again, you can unsubscribe the newspaper, and then it will no longer deliver the newspapers to you. In any case, the observer pattern defines a one-to-many dependency between objects so that those objects can be notified if changes happen in the subject. And here you can see the UML. The UML is quite simple. You basically have a subject abstraction, and you need to do three things with a subject. You should support attaching an observer to it, detaching an observer to it, and notifying an observer. So the first two methods are needed for hooking something into us so that something can observe us, the subject. And the third thing, the notify method, is needed to say, hey, something happened, react to me. So whatever observers are hooked, they will be notified. And when observer is notified, well, it just does what it needs to do based on the subject. Or maybe not even based on the subject. Maybe it just does something without any context. It just reacts. So why would you ever want exactly like events and event handlers? I'll get back to that soon. So why observer? It enables optional reaction to actions, and it decouples action from handler. And yes, in .NET, actually observer pattern is pretty much events. You still might need observer pattern in like extremely complex situations, but I would say in 95% of scenarios or more, events is good enough. So basically, the equivalent of that UML would be this scenario. So my iSubject no longer has notify method. It no longer has subscribe and unsubscribe method. Everything is under the event. So this means that we can subscribe with plus equal sign, unsubscribe with minus equal sign, and in like notifying something is just invoking this event. So that's all that there is. And you can see that in action, you create a new subject, and that subject exposes something happened event to which you can subscribe and to which you can unsubscribe. So very simple, neat way of reacting to something that happened. And you will see things like this, events and handling them, mostly in working with graphic user interface. You have all sorts of event, window minimized, window opened, application closed, application started, application ready, application sleeping, and so on and so forth, and you can react to each of those events. Why can you react to each of those events, you might ask? Because those are key moments in application lifecycle that are likely to be of interest, or maybe likely is a bad word, might be of interest. The key thing about events and the difference between events as opposed to mediator, the difference between observer versus mediator is that mediator solves the problem of one-to-many. It solves the problem of dependencies knowing too much about each other and so on. That's the problem it solves. But those dependencies are usually there. When you call mediator, you will always get handling. Some logic will be handled. It's there, it's set up, it's pre-set up. However, with observer, when you invoke an event, when you notify the subject, you might not get any response. There might be no subscribers. So observer is like a configurable mediator in that regard, that it allows you to expose something that you could react to, but maybe not. However, mediator, it always, if it does have a request, it will always have a handler. And if it doesn't, it's broken. So that's the difference between the two. So mediator is much more explicit and it always handles something that you do. However, observer just signals that something happened, and from the outside, we can choose if we want to handle it or not. And that's all I wanted to say about the two. Do you have any questions? Because I'll try to make a few short demos about each, this time from 0. Actually, this time we'll do it slightly different, starting from a test in a TDD approach. So we'll have we will have two folders, observer and mediator. And then we'll have game tests in both. And we'll start from a test. Now let's try to come up with a scenario that we want to do. And first I'll define that scenario in comments. What do I want to do? So we have a game. A game has tiles, just like in our example, right? When all tiles are colored, game is complete. React to a tile being colored as soon as we click it. So this is what we'll try to do this time. A game where you need to click all the tiles until you have colored all the tires. That's good. Yeah, nobody does demonstrate stuff in TDD really, so yeah, I really hope that'll be useful. It's good practice for me as well. So what do we need from a game? We will define it in game tests, and I'll call the game color all. Yeah, color all game. That's what it'll be. I'm not going to make complex rules. I wanted to hide the colors that needs to be colored, but for now, a simple game to simply color all the tiles is good enough. So our test case, we'll start from a test case that says is complete given some uncolored tiles returns false. And actually, there will be a bunch of cases, and I don't want to have a test case per each. Well, I do, but I don't want a separate method. I just want an input which says game expectations, game over expectations. And basically, we'll have a set of tiles. Yeah. A set of tiles. And on top of tiles, we'll have is game over. So here we have game over expectations. Let me write that. Public static, that's the syntax for defining test input. IEnumerable, that has object array, which is basically this. Object array is this, and IEnumerable is that we can have many cases, right? So I'll just write this, and it's our getter. So now I need to define those test cases, and our first test case was this one. Is complete given some uncolored titles. It returns false. So, right. First, the most simple scenarios. Let's define those. Private static object array. So is complete. So empty tiles. Game empty tiles. Game over. True. If we have nothing to color, the game is complete. So if there is this kind of a scenario, we say, come on. We say IEnumerable dot empty enumerable dot empty yeah, come on, enumerable dot empty itile. And what I'm doing right now I'm simply defining the cases, and I'll pause a bit and simply create this soon. So we have this, and the next one, the game is true. So this is my tile interface, the first interface for this program. So let's create those two, mediator and tile. I'll place that tile in the mediator for now, because that's the one I am working with. By the way, guys, if you wonder how long this might take, this will not be that fast. I might take 1 hour and a half, something like that, so bear with me. But this is really good stuff, and I recommend watching. Not because it's a stream that I'm doing, but because it's something that's very practical and applicable immediately at work. The TDD aspect especially. So we have a tile, and any tiles, game over. And this is what I return. Next will be one tile uncolored, one tile and it is uncolored, so that means the game is not over. So let's create yeah, what am I doing? New tile, new tile. Right, I'll need to now create an implementation of it. So public class tile, good enough. Note that I don't really run the tests yet, because there is no point where I consider it can fail. So I said it needs the color, and I'll say public. So tile has this color thingy, actually has a trigger, bool is colored, let's say, right? So this is what my tile has. Come on. Good stuff. That's it. So we start with a tile. Tile has nothing. When I create a tile, I pass if it's colored or not. Bool is colored. I hate that ReSharper puts it in the bottom. I'll put it at the top. And for now, it doesn't have anything. It just has this. Is it colored? Well, I said it's uncolored. If a tile is uncolored, is game over? No, it's not. The game is not over. And last scenario, actually not last, second to last, if it's colored, the game is complete. So I'm just defining rules, really. There is zero logic right now. It's just the rules of a game. And if I have two tiles, both colored, it returns true. True. And really, to me, these four scenarios cover the whole game logic. What means to have all tiles colored? What's the condition for the game to be complete? So now I'll just yield return all those one tile uncolored, game over, false. Let's copy paste this a few times. Right. So this is the test that I have right now, right? And this is the input I have. And now I have minimum something that is running and that I could see if it works. So I can verify, at least if I understood how my, syntactically, how my code is laid out. And all my tests pass simply because I don't do anything really. I just see if it is able to compile and if it is able to run what I wrote, which it is. So now I will continue. My test reads as so. It says is complete given some is complete returns is a game over. Expected is game over. That's literally what it is. So what is that is complete? The first thing before underscore is the method call. So basically what I need to create a game surprisingly I have it. How come I have it? Oh, I forgot to write tests. Okay. So this is the game. What does the game need? I guess the game needs tiles. And it will be simply a one-dimensional list of tiles, right? So all I need is to have a size of game. Or maybe just pass the tiles themselves. Yeah, let's say we are able to load our game with tiles that are either colored or not. So I pass tiles to the game. Then I say, is game over? How do I check it? I check it by saying game is complete. And finally, what's my expectation? Is game over should be true. Let me add one library because I really like using it for such style. Fluent Assertions is a really good library. Neat. Feel free to ask questions in between. This is definitely a great time. And now I just need this class, so I will create the class. Thanks much for streaming. Bye, John Bachelor. Okay. Game color all game. Right, so color all game takes tiles. It doesn't at the moment. Private read only, I enumerable, I tile, tiles. That's it. And public bool is complete. Returns false. Minimum possible what is needed of this. Public bool is complete. Return false. And if I go back to my tests, let's see what happens. all of my tests fail. Do they fail for good reason? Yeah, they do. True, true, false. So I wrote should be true, and actually I made a mistake. It should be expected. Let's try again. So one test passes, but it passes simply because I have it hard-coded. My goal is to make all those tests pass. So I need to make the smallest possible solution for it to pass. What is my condition? I want all tiles to be colored. So my check is this basically. That's the minimum possible for what is required from me. If I run my tests again, it suddenly passes. So my game is having that basic logic. And now I need the second part. Now I need tile itself. So back to tile. It has this colored thingy. And the second thing about tile, what I want is I want tile to, well, I will define what I want through tests. So public void, I want to toggle a tile. Toggle inverts is colored. Hey Timmy, I am doing test-driven development approach for implementing a small, simple color all game, and then I'll compare how the two different implementations for this little game works, comparing Mediator and Observer design patterns. So what is my theory? My theory is that if I pass true, I get false. And if I pass false, I get true. That's my theory. And what do I have? I have bool is colored. Bool expected is colored. Yeah, and it's a great way of looking at it right now. If you look, I'm doing simple stuff. I'm just writing test first, and I'm trying to figure out how the game works through defining test cases first. So I simply need to create a tile. And I create a tile which is colored. And if I say tile toggle, it should invert the is colored parameter, right? So var colored, actual colored should be expected is colored. So now I need this toggle method, right? It created one, and it returns a bool. It doesn't return anything, actually. It just changes the state, right? So what does it do? It says I need a private setter. It says that colored is not colored. How old are you, if I'm allowed to ask? You sound pretty young. I am pretty young. I don't know. What do you think how old I am? I'll answer this question, but I would first like you to guess. It's more fun that way. 17. Holy fuck. That's good, but I'm not 17. I'm not 17. But I'm glad that you think that way. Holy shit, no, no, no. No, 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 no. Tile. Okay. Nope. I'm 26. Pom pom pom. Oh shit. So my test is this. If I create a new tile, which is initially is colored, and I toggle it, and I toggle it, that means that it's inverted. So if I pass is colored, it should be as expected. So if I run this now, both tests pass, all good. So if it's true, it becomes false. If it's false, it becomes true. So now in Mediator Pattern, the requirement is that that not only I invert the color, but I also ask Mediator to do something. So I will need to do more things about this. Now it will be a bit more complex. So I need to create the game itself. With the tiles. And sorry, I don't need to do that. Not quite. I basically need to mock away the mediator, as I said. So I need mock you right now. I'll need to write some mocks. Why am I writing mocks? Because that's how mediator works. Basically, a tile will call mediator. So I'll have var game mock is new mock, and now I will need an interface for the game. So let's hit, come on, let's hit refactor, extract, interface, select this, next, done, go back to test. So I need to mock I color game. I don't need anything in particular, but what my expectation is that when I haven't explained iDisposable yet, no. Actually I did probably. Sorry. I did talk about it some time ago, I think, when I was talking about files and handling them. But it's a simple topic though. If you have any question in particular, I'm happy to answer. But I am not going to talk about it in great detail right now. So Yeah, so what my expectation is that as soon as the game is complete, you have a pop-up that says, hey, you completed the game. So I assert two things now, and there's a cool thing called Assertion Scope. I'll put that in here. So I assert two things, and I put in Assertion Scope because both things will be asserted no matter if it actually happens or not. So I need to verify that is game complete was called when I when I toggled a tile. So game is complete times once. This is my expectation. And this expectation will be broken because I don't do that. And if I click, you will see expected invocation of G is complete, but I didn't do anything. So I need to actually do what I just asked myself to do in a test. So when I create a tile, I also actually need to have a way of hooking it with a mediator. And in our case, that's color all game abstraction. So game is game. And this becomes slightly more complex, meaning which I also do is game complete. And now that I have this, I need to change this. And the way I do this, I need to pass in my game mock. Because everything now is failing and in different levels. The change that I did is a breaking change. So here I also need to change stuff. And to fix this one, and to actually prevent further changes, further breaking changes, I'll actually encapsulate the way I create tiles. Why? Because the fact that I have a mediator under the hood is irrelevant. What matters to me is that I have tiles, right? So private static tile, build tile, and all that matters is the color. To be precise, is colored, the fact if it's colored or not. So how do I build a tile? I simply say new tile, a pass in is colored, and next to that I also say mock of I game. I didn't what the crap? What do you want from me? Right, I forgot brackets. So why am I doing it like this? Why am I not creating a new mock? Because what this basically does, it just stubs away this dependency. It turns it off, but it creates a dummy of I color game. I cannot really do anything with it, but the key point is that nor do I need to do anything with it. I just simply pass it as a dependency. So this is basically saying that this is irrelevant and all I care about this is colored. So this is my build tile method. And the changes that I'm introducing now are minimum. Why are you complaining? Why is it complaining? Complaining. Build tile, right, new. It's getting late. All right. So yeah, as you can see, with minimal changes, I adapted, and further in the future, I made this change proof. All that matters is color, and this is what I pass when creating a tile. So that's cool. If I go back here, we have toggle. Toggle is color, everything is good. So we fixed everything. Let's see if our tests pass. And they do. So that is good. I should run all my tests. Yeah, it's empty. I think they passed. I hope they passed. So next on, so now I know that this part is working, which means that every time I toggle a tile, it calls is game complete. And now I just need to say that when game is complete, the requirement is to print it to the console, right? To print something to the console. So this is good, but on top of this, yeah, I need to say var is game complete, and then I say if is game complete, congratulations, you won. And this is a difficult part now, because and I need to return it's complete. Not like this, of course, but like this. So a difficult part is that when game is complete, it prints something, right? And I'm not testing that at the moment, but I need. So let's add that. New assertion scope. Again, the fact that I wrote that single line of code after that I wrote tests for that single line of code after is not ideal, but it's no biggie either, because I'm writing tests immediately, because it was a really short line of code and there was nothing to think there. Okay, but again, I should have written test first. So I need to see if it works, if it printed. So console out, because it prints, it'll be a string writer. Why is it complaining? Read only. Set out. So it's a string writer. Again, it's becoming more complex, so I'll separate it with those thingies to make my life slightly easier. So we're faking console now. This is what I did in the C# bootcamp as well. Fake console output is new string writer. Fake console output. And we are verifying if fake console output string writer get. How do I get content? Flush the string. Does it work? Does it do the string the way I expect it to do? Let's see fast. Probably it doesn't. It does have an override, so I assume that will work. So output, I expect that output expected output, it should be hard-coded. So expected output, yeah, when message, no message. So I'll say private const string when message, private const string no message, or string empty is good enough. And then let's go to color all game. Congratulations, you won, blah blah blah. Yeah. So basically what I'm saying is that there is an extra parameter that goes in my expectations, and that is probably not needed. Yeah, probably not needed. I'll just have a dictionary, private dictionary bool string when messages. So yeah, basically if it's true, it's when message. If it's false, it's string dot empty. New dictionary. Okay. Cool stuff. Private read only. Private only dictionary bool string cannot initialize of type char. Bool string. Huh? What do you mean char? Okay. This is good. So var expected message is messages is expected game over. And then I say output should be expected message. Let's see. Expected output to be congratulations, you won, but it was unexpected white space at the end. How do I fix it? I could say should contain and assume that's good enough. Though again, that's bad because if it's empty string, should contain empty string is, you know, quite bullshit. So I should again be smarter than this, and I'll probably just trim the message and change it back to should be. Because you see this one started failing. So okay, what's wrong? Oh, this should be trimmed. Expected message. No, output. Output should be trimmed. Yeah, let's try again. Because I don't care about white space in the end. This is the mistake I did in your guys' tests and first chapters. I did not trim, and that's why people were complaining. So yeah, this is working. This is awesome. So now I can create a game and see if it works. Obviously, I need one last thing. To trigger the tile that I want, right? Or do I want that? I do. So basically, again, start from a test, calm down. That's to me. I should calm the fuck down and start from a test. So public void press given tile press given tile index exists. Toggles it. Yeah, that's good enough. So that's my first scenario. And my second scenario is press given tile index does not exist, throws. What does it throw? Index out of range exception. Or better so, invalid game setup exception. Okay, let's create the easier one. So minimum viable setup, what would that be? I need a tile. So many tiles. I actually need a mock itself. And then I need tiles that would include my mock. Then I need to create a game. That would have my tiles. And what do? I have this press tile index 0. What's my expectation? My expectation is that the tile of that index will be toggled. That's all. I don't have toggle method of tile? Really? Okay, that's a problem. Void toggle. Cool. So this is literally it, and now I just need to create this method. So again, what did I want it to do? For now, nothing. I'll just make sure it fails. I'll just make sure it fails. So if I go back here and run my, oop. It failed because I didn't toggle the tile. So now I'll go back to my game and I do the toggle. I need to pick the tile of that index. So I say tiles, get. There is no index here, so I need to actually change the implementation. Something more sophisticated. Spam. Actually, array. Literally array itself is good enough. Okay. And what do I do? If tile index, actually nothing. For now, the test doesn't ask me to do anything. It just asks me to given tile index, toggle it. That's all it asks me to do. And now I run that test and see what happens. The test passed. So now I go on with another one. What happens if tile doesn't exist? The setup is similar, but way less complex. Because I have a game without tiles. So if now I interact with the first tile, what's my expectation? My expectation is that it should throw. What should it throw? It should throw invalid game setup exception. And I don't have this exception, so I need to create it. And I'll say int tile index, and I'll say base tile at given index was not found. Index was this one. Whoops. Right. Index tile index. Okay. And if we go back to test, I said if we go back to test, we have that it should throw an exception, but I'm not very happy with that. I'd also like to say and, or more like which message should contain. The main info that I'm looking for is index, and that index is 0 because we passed 0 index. Let's see if it works. It does not. Let's see why. Index was outside the bounds of array. But index out of range was thrown. So wrong message was thrown because we don't handle this yet, right? Of course, we don't. So if tile index is more than tiles.length, or tile index is less than 0, we basically say throw new invalid game setup exception, and we pass in the tile index. Let's go back. It still fails. If tile index is more or equal, we left a bug because it's 0 and tile's length is 0, so it cannot be equal. Yay! Test pass. See, it's quite fun doing TDD and, you know, not letting bugs through. So I literally just made a basic game with the functionality we want, and now let's just test it if it does what we want in reality, right? So I'll actually do it my usual way. Just create a static class that runs the demo, so we can compose demos. What demo is it? It's Mediator demo. Public static void run var game is new game with tiles. Let's have a bunch of tiles. Private static build tiles. How many do we want to build? Let's say 10. I mean, what am I even doing? Okay, I'm getting sleepy. Fuck. And tiles. So for tiles, we basically say, probably can do it smarter. I can say tiles is new list of tile, and then we can say tiles, then we can say enumerable repeat. What do? I do tiles add new tile that is not colored, and I do it 10 times. Okay. What the hell is wrong? Right, I need to pass the game itself. And this is a problem now, because how do I do that? Because one refers to the other. Well, I basically need the second constructor. That creates those, which I dislike. Add tiles. It's a workaround, really. That's why Mediator is bad. It's great. I mean, can be bad. It's great that you noticed that. So I'll literally just do this. Set tiles, let's say. again, I should test it, but yeah, I should test it. How do I test it? Public void new game has no tiles. And next one, new game with one tile. More like set tiles. When no tiles, given one tile, assigns has no tiles. Okay, so var game new color game new array with mock of I tile. Cool. Equals. And then let's say game dot set tiles and enumerable empty. And again, this should be true. Let's run all the tests. I am having some issues. Right. This takes a game. Okay, what do you want? Oh, right. No. Oh, right. Tiles. Tiles, I have ambiguous names, right? Tiles count. Tiles, add new tile, false, game, tiles count. What's wrong? Repeat element, count. Oh, I think it creates it. A sequence that contains repeated value. Yeah. So I can do this. Cool. So we have build tiles. How many? Well, first the game. Then the tiles. We build, let's say, 5 with the game. And then I say game, set tiles, tiles. Everything is tested. I trust it works, 100% trust. Yeah, so now I just need while game is complete. Guess a tile. Console var tile. Console int parse console.readline. Yeah, that's good. Yeah, that's good. Again, what's the problem? Right. All I need to do now. Good night, Hill Hunter. All I need to do now is to run this. Poop. So demo, run, see what happens. Guess a tile. Well, first, actually, let me change this to just right. Guess a tile. So we have 5 tiles, and I need to basically guess 1, 2, 3, 4, and really? What the fuck? Good luck at work. Tiles count was 5. Oh, I don't do with anything with tile. Oh my god. Okay, tile, press, tile. Okay. So 0 and I won. I can do while true. Or while not bored. Go int try parse console read line out var tile. Okay. If is number is continue var is continue true while is continue do it and press a tile. Cool. Okay. Okay, fixed. So guess a tile 0 and it says I won. Guess a tile 0 and it says I won. Why? Is game complete? Let's see. Because it makes no sense to me. So I press the tile with index 1 and I toggle it. And I check if game is complete. And I check if all tiles are colored. And it says yes, all tiles are colored. How come all tiles are colored? Oh. So we made a bug in the game setup. And the bug in the game setup is that I basically created the game with all the same objects. And that shouldn't have been that case. In my demo, this basically creates duplicates. And this is not supported. Repeat, reverse, create or something. I don't know. Doesn't work. This one doesn't work. Can I refactor quickly? I cannot. Let's do a for loop, I guess. For tiles count, yield, return this. Okay. Now let's run. 0. Okay, now it works. So now I need to basically type 0, 1, 2, 3, and 4, and it'll say game completed. Okay, works. Awesome. And I just need to stop. So if is continue, do this. Cool. And if I press 6, it says poop. Okay, cool, works as intended. So this is Mediator, and we already witnessed the problem that it was difficult to communicate with those tiles, right? Quite difficult, quite annoying, and that's why in those examples it's actually usually a property that does it, that sets those dependencies, and not a constructor, which is very annoying, very dirty. And let's do a event-based approach. And let's do an event-based approach. And let's do mediator-based approach. But I won't do these two, I'll just do observer because I'm sleepy. Okay. Now it's gonna be just mostly porting code from one place to another, so bear with me, not very interesting, not in particular. So this is the same. This is the same. Yeah, this is the same. Nothing changes here, really. demo doesn't change at all. However, tile will change quite a bit. Yeah. So our tile now will have those methods. IObservable. IObservable has void attach. Not IObservable, but ISubject. It can attach IObserver. Come on. It can deattach IObserver. And it can also do what? Update. Sorry, notify. Yeah, notify. Right. What does it have? Okay, I don't want this one. I want, I'll just call it game. Well, it doesn't have to be game. This namespace is not needed. Oh, right. So I can just add the interface, right? Void update itself or something based on what happened. Yeah, this is public, of course. Alrighty. So we have this, we have that. And this goes to its own class. So all is great. So tile is really a subject as well. And since it's a subject, it implements those three methods. The key point now is that the game itself is no longer there. And toggling will simply call notify. However, instead of a game, we'll have observer. Many of them. So let's initialize that like this. Game no longer relevant. That's it. So attach, deattach, super simple methods. We add observer. We remove observer. And notify simply says yeah, for each to just update. Yeah, that's cool. So now the game is not needed. Kind of. That is good. However, in our demo, I should write this for that, but I won't write today because we're tight on time. What I will do instead, I'll just refactor with a different approach. So we have observer, we have color all game, which is great. So what is missing is I observer. So I need to implement that method, and that method is simply is complete. That's what that update does, right? And that's it. So I'm done. In my game, now I don't need this method as well, nor this constructor. So I'll build my tiles without the game. Then I say, this is observer demo. Then I say, okay, cool, game. Yeah. Never. Okay, so we have this. What I need to do now is to say that for each tile, I need to attach a tile. Yeah, I should have that. Tile, right? Tile, attach. Oh, it's a bad namespace, right? No, it's not. Oh, it's iTile. I am not building iTiles. I'm building tiles, right? I should update my interface actually. Yeah, tile is actually a subject. Like this. Okay, so now it's available, the method to attach the observer, which is game. So for every tile, I attach the observer, which is game. And that's it. So if I run the observer demo here, and comment this one out, run. Let's see. Uh-oh, didn't work. Didn't work. You know why it didn't work? Because I didn't write tests for it. Okay, so I built 5 tiles. I press the tile. So I attach the observer. And I press the tile, which toggles this. And when I toggle that, it notifies all of my observers. So it all makes sense to me. Let's see what went wrong. Whoa. Okay. Okay. Okay, 0. Attach, add observer. Puzzled. I did attach here the game as observer. Why didn't it attach? Yeah, observers add. So tile, this tile should have one observer. The fuck? Okay, and there are 5 tiles with 1 observer each. 0, 0, 0, 0, 0. The fuck? I don't get it. It's not a struct, it's not by copy. The fuck? So this tile has definitely 1 observer. And it's the same tile in the list. Has to be. It's the same tile. What the hell? Same tile. This doesn't make sense to me, honestly. Oh. Is it because I do this? Oh, oh, oh boy. Oh boy. Okay. That's actually the first time in my life I dealt with this as a problem. Wow. Just wow. Basically, this doesn't exist. Every time I for each it, it does this. So every time I for each it, it doesn't exist. Therefore, a tile that I set here doesn't exist. So that's very interesting. I'm so happy that I saw this. So now it works. So that's what the warning says. Wow. Yay! Except if it's continue, guess a tile. Oh, right. I put it in the wrong place. Wait a minute. Yeah, this is good. Okay, whatever. This is not needed, actually. Whatever. This is good. So, I'm done. I'm done. So, if I press this, and then this, and then this again, game 1 again, and then if I press enter, it exits. Awesome. So I just made the game in observer pattern, in mediator pattern, through TDD. I'm so happy that I pulled it off, and thanks everyone who are watching. Do you guys have any more questions maybe before I pull back and go to sleep? If not, I'll take it away. So thank you guys for watching, and good night. I hope you had as much fun as I had teaching. Bye bye.